This video is going to introduce you to what relations are. Please make sure you have your notes sheet with you and you're ready to start taking notes. This unit we're about to start is all about relations and functions. A relation is a set of ordered pairs. We talked about ordered pairs on Friday when you were graphing them on a coordinate plane. So a relation is just any set of ordered pairs. You should write this definition on your note sheet. Here's an example of a set of ordered pairs, or a relation. In this case, I've just chosen 3 ordered pairs, but a relation can be 1 ordered pair, 10 ordered pairs, 30 ordered pairs. It can even be infinitely many ordered pairs. You should record this example on your note sheet. A relation really shows a relationship between input numbers and output numbers. In each ordered pair, you have 2 numbers, an input number and an output number. In other words, your x value and your y value. X is your input, y is your output. The next 2 terms we're going to talk about and define are domain and range. Here's that same example of a relation, so you don't need to copy that down again. The domain of a relation is the set of all the first numbers in the list. So you need to write that down as your definition for domain. It is the set of all the first numbers in the list. So for this relation that we're looking at, the domain is 1, -2, and 0. You'll notice that when we write the domain, we use these curly brackets. It's the same curly brackets that are around the whole relation itself. And this just means that we're talking about a set of numbers. So we're talking about the set 1, -2, and 0. It also doesn't matter what order you put these in. Some people like to put them from least to greatest, but it's still a set no matter what order you put them in. So of course we have another name for the set of all the second numbers in the list, and that's called the range. So you'll need to record that on your note sheet. Let me change my highlighter. So the range of this relation is all the second numbers, 2, 4, and -3. So the range of this relation is 2, 4, and -3. Again, it's inside the curly brackets because it's a set. The last word that you're going to define on your sheet is inverse. The inverse of a relation is obtained by switching the coordinates in each ordered pair. So here's our example again. Again, you don't need to write it down again. You already have it written down. The inverse of this relation is when we take each ordered pair and we just switch the x and the y coordinate. So for each ordered pair, I'm just going to flip-flop x and y. You don't have to write those arrows. What happens is you get a new relation that's just the reverse, or the inverse. Instead of 1, 2, I have 2, 1. Instead of -2, 4, I have 4, -2. Instead of 0, -3, I have -3, 0. Okay, at this point, I'm sorry, I've gone too far. At this point, I want you to pause the video and try the example problems, the example that I gave you on your notes sheet. Okay, let's check and see how you did. So here's your given relation. The domain of this relation, make sure you have your curly brackets, would be 3, -5, 2, -1. If you can't make the curly brackets perfectly, as long as they don't look like parentheses, you're fine. The range of this relation would be -5, 4, 7, and 6. The inverse of the relation would be negative 5, comma 3, 4, comma negative 5, 7, comma 2, and 6, comma negative 1. Again, make sure you have your curly brackets or the best that you can do. Something to keep in mind when you're listing domain and range is that if one of the numbers repeats in the domain or the range, you do not have to write it twice. So for example, if I had an extra point in this relation that was negative 5, comma 6, when I go to write my domain, I've already put negative 5 in the domain, so I would not have to list it again. And same with the range. I've already have 6 in the range, so I would not have to list it again. Okay, so let's move on. If you would flip your page over to the back, you now have headings that says ways to represent relations. We're going to talk about 4 ways to represent relations just to start off with. The first one we've already done is just to list the relations. So this is the same example we had on the front side. You're going to write this down in the list section of your chart. Remember, again, you need the curly brackets because it is a set of ordered pairs. Anytime you have a set, you need those curly brackets. Another way to represent a relation is a table. So on your paper, you have a section marked table, and there's already a table drawn for you. I'm going to draw one here for myself. So what we're going to do is we're going to make it an XY table. So you want to put in the headers X and Y on your table. And all I'm going to do is write in my ordered pairs. My first one is 1, 2. My next one is negative 2, 4. And my third is 0, negative 3. So that is how you can represent this same relation, but as a table. There is another way to represent a relation called a mapping, which you probably have not seen before. In a mapping, there are 2 ovals. The first oval is where we're going to put our domain, and the second oval is where we're going to put our range. Now, when you make a mapping, it actually does not matter what order you put the numbers in, and I'll explain to you why in a second. Let me check that those are the right numbers. Negative 2, 4. Nope, they're not. Okay, so because I purposely did not put the X value right across from its own Y value, although these did end up across from each other, because in a mapping, to show which input goes with which output value, or which domain value goes with which output value, we actually draw an arrow from the input value to the output value. So I'm going to draw an arrow from 1 to 2. I'm going to draw an arrow from 0 to negative 3, and from negative 2 to 4. And that's how we show which input goes with which output. I could have just done them right across from each other and just an arrow straight across. If I had a point in here that repeated, for example, if I had another point like 1, 5, I would not need to write another 1 in my domain. I would need a 5 in my range. Then I would just draw another arrow from the domain value to the range value. So you can have repeating numbers and just draw more than one arrow. And the final way to represent a relation is with a graph, and that's what you practiced on Friday. So all you would do, of course, is just plot your points. 1, 2, -2, 4, and 0, -3. Notice I do not connect the dots. We are only talking about these specific ordered pairs, so they do not need to be connected. We're not trying to make a figure. All right, finally, there are other ways that we will represent relations and what we're going to talk about soon, which is functions. And one of those ways is as an equation. So actually, this equation, y equals 2x minus 3, is actually a relation. How is it like a relation? Well, just like a relation, it has x and it has y. Just like a set of ordered pairs has x's and y's. Do you see any ordered pairs here? Well, no. But we could create a set of ordered pairs based on this equation using this x and this y. So what I could do is I could create a table of values out of that relation, that equation. So that's what I'm going to do, and that's what you're going to do on your paper. Again, we're labeling the headings x and y. Now I can choose anything I want for x. Nobody's going to tell me what to do. But I think a real easy number to choose is 0. So if I were to plug in 0, then this would say 2 times 0 minus 3. Well, 2 times 0 is 0, minus 3 is -3. So there's my first ordered pair. Again, I can choose whatever I want, so I'm going to choose 1. 1's an easy one. 2 times 1 minus 3. 2 times 1 is 2, minus 3 equals -1. So when I plugged in 1, my output, or my y, was -1. So I want you to pick a third number for x, fill that in on your chart, and figure out what the y value would be. This concludes your introduction to relations. Please make sure that you bring this to class with you, and we'll go over it together.